Now what is meant by normal to a plane? We always know normal is always perpendicular to tangent. So in this, what is meant by normal to plane? A line which is perpendicular to every line in the plane is called normal to plane, and normal to plane is denoted by vector n. So if we have a plane and if there L is a line, then n will be perpendicular to L. And if this is a line M, then N2 will be perpendicular to M. So, any line which is perpendicular to every line in the plane is called normal to plane. So, normal to plane gives the direction of plane. Now, we have to find vector equation of the plane passing through a point with coordinate A and having normal n. Now, let the plane passing through a position vector A and having normal n be pi. The plane pi contains the plane passing through point A and normal n. Let P of r be any point in plane pi, that is P of r belongs to pi and A is not equal to P. So let us draw the diagram. If this is plane and a line is passing through, plane is passing through point A and P of r is any point in the plane and this n is perpendicular to this line and normal to plane. Therefore, AP will belongs to plane pi, which implies AP perpendicular to normal n. And if two vectors are perpendicular, their dot product is 0. So position vector of AP are r minus a dot product with vector n is equal to 0. And if P is equal to A, then vector r is equal to A. So r minus a dot n is equal to also 0. That is hold good. Therefore, P or r belongs to pi then r minus a dot product with n will be 0, which is a required equation of vector form of the plane. Conversely, that is, if P of r is any point in space such that dot product of r minus a dot n is equal to 0 is given. That implies AP perpendicular to n, because if dot product of two vectors is 0, then vectors are perpendicular. And as AP perpendicular to n implies A belongs to pi, that is P belongs to pi. Thus, it is proved P of r belongs to pi if and only if r minus a dot n is equal to 0. That implies r dot n is equal to vector a dot n, which is vector equation of the plane passing through point A and normal n. If we suppose, that is, let a dot n is equal to d, then r dot n is equal to d. That is another form of vector equation of a plane. Now we are going to find Cartesian form of a plane passing through a point A and normal n. That is, let vector r is with coordinate x, y, z, vector a with coordinate x1, y1, z1, and vector n with coordinate a, b, c. Then vector equation of plane r dot n is equal to d becomes, where d is equal to a dot n, that is dot product of x1, y1, z1 with normal a, b and c. So we get x1 into a is ax1 plus by1 plus cz1, that is d. Therefore, substituting r, that is x, y, z into normal component a, b, c and dot product is equal to d, that is ax1 plus by1 plus cz1. So we get ax plus by plus cz is equal to ax1 plus by1 plus cz1, which is d. So we can write equation in the form ax minus x1 plus b y minus y1 plus c z minus z1 is equal to 0, or ax plus by plus cz is equal to d, where d is equal to ax1 plus by1 plus cz1 and a square plus b square plus c square is not equal to 0 as n is not equal to 0, which is the required equation of plane in Cartesian form. Now we are going to solve problem based on equation of a plane passing through a point and normal. So the problem is, find the equation of the plane passing through four, 5, minus 1 having normal 3I minus j plus k. So here we have a is equal to 4, 5, minus 1 and n is equal to 3I minus j plus k, that is 3 minus 1 and 1. So as we know, r is, or we can say let r is x, y, z. Therefore, the equation of plane is r dot n is equal to a dot n. So r is x, y, z dot n 3 minus 1, 1. A is 4, 5 minus 1 dot 3 minus 1, 1. That gives 3x minus y plus z is equal to 12 minus 5 minus 1. So that gives 3x minus y plus z is equal to 6. So which is the required equation of plane. Now the next problem is, find the normal and vector equation of the plane 2x minus z plus 1 is equal to 0. So in this we have the equation of plane in Cartesian form. From here we have to get the value of n and then we have to find the value of passing point and then form the vector equation of plane. So let's see how can we do it. Now the solution is, the given equation plane is 2x minus z plus 1 is equal to 0. That means 2, 0 and minus 1 dot product with x, y and z plus 1 is equal to 0. That is a dot b or b dot a is same. We can write x, y, z, that is r dot n, that is 2, 0 minus 1 is equal to minus 1. So on comparing, we get r dot n is equal to d, where n is 2, 0, minus 1 and D is equal to minus 1, that is A dot N. So this is all about the problem.